Hello everyone, I am Niharika D from grade 8 and these are my friends Anish of grade 7, Gaman of grade 6 and Unnati of grade 9. We are from Janani Vidya Mandira. It is my great honor and privilege to invite our special guest for today's interview, Mr. GSV Bapiraju sir, who is into operations and tracking at Indian Space Research Organization. ISRO, as we all know, is India's national space agency known for its remarkable contribution in space exploration, satellite launches, and satellite advancement. Mr. GSV Bapiraju sir has been integral part of several important missions. Today we are very fortunate to have him with us to share valuable insights about satellite tracking and operations and his experience at ISRO. On behalf of Janani Vidya Mandira, I extend warm welcome to Mr. GSV Bapiraju sir and thank him for taking the time to join us. Thank you, sir.
Thank you.
Sir, what does operations and tracking management of satellites actually mean in simple words?
Actually, tracking means we are sending satellite. The satellite, what it is contains different subsystems. Like our how subsystem means in satellite purpose is we send satellite for communication, meteorological, that is weather report, and earth resources, finding earth resources, and now navigation. These are all the things. And one more is distress signals. Distress signal means suppose when you are in distress of aeroplane or any whichever is distress and ship. So these signals it is received. Okay. So what it is satellite will contain is subsystems, different subsystems. That is like our human, how you say brain. So we have and detectors, eyes and all for like our eyes, which gives the information. Eyes, what it is, it will sense that. So we send the satellite, okay, to detect information or sense the information remotely, which will not be in physical contact with the object. With the object remotely. Remote means without touching any physical contact. So this is tracking means now satellite is in orbit. So this satellite tracking means what? Information, that is where it is located in space. I have to identify the object where it is located, and for that what we do is we send one signal from earth to satellite and receive back. So that signal will tell how much far it is there from us, and how it is moving. That information we record and we'll process it, and with that we'll predict next 1 hour after that where it will be, next 10 days where it will be. So in space, locating a position of any body, it is called tracking.
Yes.
Okay. And operations means we do some commanding. That is from say spacecraft, what we do is spacecraft is having different subsystems. That subsystems health we are monitoring. Health, it is like we are doctors other way. So satellite doctor, that is each subsystem how it is performing. Okay, whether we within the limits or not, performance like our body health, how do we measure? So like that. So that information we receive from satellite. If the subsystems will tell that, okay,
Yes, sir.
that information we receive. And commanding also we say that. Suppose now I have understood some satellite, I have sent the satellite. Now what it has to do now? There are cameras are there. For the satellite will like a camera will be there, or some detector where camera should be on, what time it should be on. Okay, how then what time it should be on and all we do it. Commanding, that is we send some command to satellite, that is one information to the satellite. Okay, so then it does the work. So it will make camera make on, and what time is supposed to be off, that also we do, that is commanding. Okay, telemetry means what, health, spacecraft of the health. Tracking means position. Okay, and commanding means it is what we send the information and what it does.
Sir, can you name any two subsystems of the
Very good. It is like our brain. There we have attitude control subsystem. Attitude control. That is in space satellite. So much it how the orientation of the spacecraft is important. It should not be simply tumbling. Tumbling means it should not be simply rotate, shaky or anything. It should not. So we define one axis. Okay. So that axis should point to exactly what we want. Okay, so this is attitude control, and there are other subsystems, like I am sending a command, and it is sending data also. So for that there is a one telemetry system, a telemetry tracking, like that. Tracking I told you. So information I am sending one command and receiving. So there is one tracking unit, that is one transponder, we say that. Transponders, okay, that it does. Next, command, whatever I send the information, it should decode. What it's supposed to do, it does. That is telecommand. And detectors. Detectors means what? Cameras, or suppose sensor is sensors. So what you are going to get the information from satellite. Okay, suppose there are different types of communication satellites are there. Communication satellite, what it does, it receives the information and sends the back. So then it is called communication. Okay, so this way. And thermal system. Thermal system is what? Body spacecraft temperature also has to maintain, like our human temperature. How what we say, it is human temperature 98.7 degree, we say no, human Fahrenheit.
Yes, sir.
Okay, so that temperature we should maintain, our humans. So like that, there also space, in the space satellite temperature also, that is thermal subsystem. And at the after this one more is thrusters, we call it as. Now satellite in orbit, so many, that is sun, moon, it will obstruct the motion of the satellite, and cosmic dust. Okay, so what we have to do is, we have to keep again desired altitude. Altitude means height. And orientation also. I told you orientation, axis, to define the axis. So for that we keep small rockets also. That is called thrusters. Thrusters. We call it as thrusters. That is, suppose like these are all. Here you see, these are all, this is rocket. So these are all rocket parts. Like the small thrusters will be there.
Yes.
So that will orient. So AOCS is attitude control system, thermal, TTC, we call it as TTC is telemetry, tracking, and detectors and sensors. So these are all subsystems.
Sir, what is your daily routine while working with satellites?
Okay, daily routine is, I said no, that is our main purpose is to serve the users what they require. Users, suppose you want to have rural area image you want to, because you are, if you want to take image, it takes a lot of time for you.
Yes, sir.
So once if you take satellite, one at a, you can cover over entire Bangalore at a time. Okay, so what our job is to operation is spacecraft health monitoring and making the detectors or cameras on and off. These are all operations, we call it as. And it will record the data, or it will send the data to Earth. After say imaging that data, you have users, different users. So users like say city planning and all. Suppose you have taken this image, Bangalore image, then you can give it to Bangalore urban development for Bangalore mapping and all. So these are all called operations. What we do is um, sending command to satellite and getting the information. That is the thing.
Sir, how do you make sure that satellites stay in orbit?
Would you say it is satellite orbit means once any object rocket if it is injects about 200 kilometers from earth, suppose this is earth, if you think this is equator, this is poles, north pole, south pole. Okay, do you know no north
Yes,
pole,
sir.
south pole and equator? So away from this some 200 kilometers above, rocket whichever injects the orbit with the velocity of 7.2 kilometers, 7.2 kilometer per second. So it itself will be rotating. It itself will be. It is like a throwing a ball with the velocity of 7.2 kilometers per second. So then it itself will be in the orbit. Okay, any object. So then we have to maintain orbit means I told us in the space main earth gravity. Earth also pulls any object towards the center of the earth, and sun, moon and other planets or anything, they will act on this small body.
Sir, and the Earth will be rotating around the sun, sir,
Ah.
right? Then the satellite should also go around the Earth itself.
Yes.
So they'll when the Earth is rotating around the sun, how will the satellite make its orbit? Should it make on its own, or you will send any commands?
Nothing. I told a rocket when it is injects into the orbit. Now, sun, moon, secondary. That is now. Now, primary body is Earth. So, my aim is to rotate around the Earth. Am I correct?
Yes,
Suppose
sir.
if you want to sending to Mars, so Mars should rotate around the Mars. So satellite should rotate around the Mars. Okay. So like that, we inject the body with required minimum is 7.2 kilometers per second it should be. So that capacity should have the launch vehicle. Okay. Then it will be automatically any body, it will be rotating on this. Now I want to orient. What I told earlier, now so many objects in the space, it disturbs the motion of the satellite. So I have to orient, decide direction. So what I told, some thrusters. Thruster I told no, thrusters will, I will fire it. Fire. So it can make height, how increase the altitude or decrease the altitude. So like that. And orientation. Orientation means you know axis, no x, y, z. You say no.
Yes, sir.
You are aware no x, y, and all in coordinate system.
Yes, sir.
So here third dimension also z will be there. 3D.
3D.
3D. So that we have to orient all three axes in the space.
Sir, what is the primary fuel for a rocket?
That is once it is injected means there is no fuel required. No fuel required to rotate like our bus and all, diesel and not required. Once it is put in the orbit, it's that injection velocity we say that. With that speed only it will be rotating. No fuel is required. Where fuel is required? To maintain small corrections.
Thrusters.
Thrusters to make small corrections. Once it is injected into orbit by the rocket, okay, so when it is rotating, that will be rotating only. Any body. Okay, so now moon it is itself, how it is rotating, other fuel is given?
No, sir.
Around that?
No, sir.
Because it is such a velocity it has thrown from there, so it is around the earth.
Yes.
You understood?
Yes, sir.
So,
Sir, can you please let us know what you do in satellite operations and tracking?
just I told, no, tracking I told.
Sir, but operations like how you handle
Operations,
it with...
operations means there are Regularly we do, whenever we have, now I will tell you. Now satellite, it is in orbit, means I should receive the information. So how do we receive? We will have different stations, we call it ground stations. Ground
Stations.
ground stations, that is like antennas, big antennas we will have. Big antennas that receive signal from some satellite, that it receives, and that data, wherever the antenna you keep in the globe, throughout the globe world, okay, so many stations are there like that. So many countries are having their own
Antennas.
antennas. So whichever antenna you want to have, you specify the time, that time our satellite is coming. Like that, if you tell, they will receive the data. Data means spacecraft health data. All subsystems I told you, that
Yes,
data.
yes.
That data we will receive, and then here we do commanding. That is, from Bangalore is for, we are controlling remote sensing satellites below 1,000 kilometers from Earth.
Sir, can we give a command from ground stations to satellite?
Yeah, I will do. That is only whatever I communicate to ground station. Now I sit here, and my antenna is somewhere in North Pole. Okay, I give here the command, from that information from my computers. It will go to satellite, that which station I told now, that ground station at North Pole. If I have kept the antenna there, then my satellite is over that. Suppose over North Pole when it is going, I will receive the data from there to here. Okay, they will, that there is one ground station will be there. They will receive the data immediately. They will send to Bangalore. What I do immediately, what I have to do, the commanding, that information I will send from my computers to
Satellites.
satellite through that antenna.
Antenna.
So
Ground
that
station.
that ground station.
Yes.
So from here to that ground station to antenna, antenna to satellite.
Yes.
It all will be in seconds. Within some milliseconds it will go. Such a fast it will.
Sir, what is the most challenging part of your job?
Challenging part is, suppose like us only satellites, different subsystems I told, no? Okay, all subsystems should perform, and life of the spacecraft, some we say that once we have put in orbit, some 5 years, 10 years it should work. Okay, without any failure. Suppose any failures happens, we have to recover that subsystem. That is, for one satellite making, sometimes it will have some other system also, like in aeroplane, 2 engines, 3 engines we say, no. So engine changeover, like that, there also we command from here to reconfigure. That is one system I configured there. That system, if it is not properly functioning, I will change the other system. Okay, how quickly we have to recover without affecting the user's required information. Suppose now I asked me to give Bangalore image,
Yes, sir.
but my satellite is not functioning. Again I want to take the image, means I have to wait for some 10 days again, or Bangalore from same satellite.
To configure.
So I have to get ready, so that immediately within 2 orbits, that is one orbit we call it as some 100 minutes for our satellites. Actually, remote sensing satellites, orbit period, we actually polar sun synchronous orbit, we say that polar sun synchronous orbit, which are all some 700 kilometers from Earth. Okay, that we are controlling from here, and this is, we take images. Okay, so these images different users will ask. Suppose that user, if any problem, I am unable to solve, it is catastrophe. So I have to recover. That is the biggest challenge. And my experience, and apart from this, this is called recovery operation. Other than that, challenging, what we have done is sending a satellite to landing on the moon surface, and we have sent that is moon is from here 3,86,000 kilometers from Earth. 3 lakhs, though it is looking near to you, okay, but 3,86,000 kilometers we sent one object, and that we made to land on the moon, that to south pole, that is at the moon south pole. We are the first person to reach the place, to land a object there. Lander we call it as. Okay, and Mars, from here to Mars, 400 million kilometers. We have sent on a satellite to there and made the life. Okay, that is to we designed for some 6 months. Only to just inform, first time we have sent, but it worked for 6 years. For 6 months to 6 years.
Sir, still it is working?
Now it is over. Okay.
Sir, what kind of satellites do you usually work with, like communication, weather,
Yeah, one
navigation?
second. Yeah. Actually, fundamentally, satellite means there are different types of satellite purpose-wise. Communication satellites, okay, meteorological satellites, and remote sensing. These are remote sensing satellites, and now navigation satellites. Navigation means what?
Google Maps.
Google Maps and all. Navigation means nothing but where you are positioned. Where
From
you
where
are
we have
positioned.
to go.
Where you are positioned also. You should know now where in
Current location.
current location. So these are all the communication. Okay, these are different types of satellites. Communication satellites are, this is if you take Earth. Okay, this from here equator, above equator, 36,000 kilometers, 36,786 kilometers away from the equator. Equator. So these are all communication satellites. Okay, these satellites are controlled from MCF Hassan. Hassan is there now in near to Bengaluru.
Yes, sir.
Okay, these satellites, what it is, they do communication satellites and meteorological satellites also. That is weather report, cyclones and all, weather, how it is, how the wind over the sea, and all information is received from MCF Hassan. That is communication satellites. These are all INSAT, we say, no? INSAT, okay, and GSAT. GSAT is that is also geostationary satellites. These are all for communication satellites and meteorological satellites.
Sir,
One second.
Yes, sir.
And these are all geo satellites, 36,000 kilometers. And MEO satellites. MEO means middle Earth observation orbits. They like GPS, and ours is ISRO also having Indian navigation systems also. We are also our Indian region, this navigation we are using IRNSS, we call it as. And what we work from our ISTRAC is remote sensing satellites, which are all polar sun synchronous. That is Earth, if you take pole to pole, north pole to south, it will be rotating. So these are all one orbit completion, 100 minutes it takes. Okay, these are all called remote sensing satellites, which we use to locate or take images of Earth resources, atmospheric study, and what you call cosmic rays study, that is gamma rays and X rays. Okay, and next to that ocean studies, over the ocean, how the fish, where the fishes are more located, algae and fungi, you say, no? So where in the ocean, where it is much, where the fishes will be there. So this information we give to fishermen. Okay, these are all the different types of satellites we are using.
Sir, when an asteroid is coming to hit the Earth, how the satellite will sense it and send what is
Yeah.
the information?
This is asteroid is it comes, it's a what you call coming to earth and all, that is another part. Cosmic dust, okay, these are all affect the satellite motion of the satellite. And suppose sometimes what will happen, that high energetic radiation rays falls on the satellite and it spoils the electronic systems. It is satellite is nothing but one electronic and mechanical, all the components, but mainly the solar panels. Okay, solar panels will be outside. Okay, so these are all get affected due to that cosmic rays and astronomical bodies. So this will definitely impeach the satellite and spoil. But there are some recovery procedures. Sometimes may not be reversible. That is, we cannot get back also. Okay. But when suppose anything, if it is coming to about the hit, so that time we may change the orbit or we take precautionary measure by switching of the some systems. Okay.
Sir, what happens if the satellite stops working, sir?
Stop working means
And
what?
it cannot be fixed. That time we
No, no,
leave
that
it.
is that suddenly keep fixed means, suppose I should know which system is failed. So suppose any recoverable procedure or anything can be done, we do. Okay. Suddenly stops means subsystem failure. Rotation cannot be stopped once it is injected in the orbit. Unless that satellite altitude, because of earth more gravity, it may re-enter into the earth. Okay, got my
Yes, sir.
point?
Yes, sir.
So it may re-enter into earth. Again, when it is re-entering into earth, it becomes it burns when it is entered into the atmosphere.
Have you ever faced an emergency situation with satellites?
For us, every orbit is like emergency only. How it will be next orbit, we don't know. Okay, but we have seen, we have faced, and suppose spacecraft health is very good, all subsystems, I told no, AOCS, sensors, all systems are working well means, only just we have to do health is okay like that. But if any subsystem failure, it takes sometimes hours together. Orientation, if it's attitude orientation, some sensor failed and we have to configure other sensor and again normalize. It may take some hours together. Okay, these are all the things, emergency things.
How did your team respond to the situation?
It is actually spacecraft operations is not by one person, or it is a teamwork. So we have to there, suppose any system failure, we start with the designers and whatever the procedures are there, that procedures we uh, implement and transmit the commands and get back the things. So it is a teamwork. 24 hours our work will be there.
So was it difficult to take that decision, sir?
Yeah, sometimes some systems you are okay. Decision is, suppose any system failure. Okay, whether it is correctly working means no problem. We will go to other system and recover. Sometimes irreversible failure is happened. So that time whether to continue or not, we have to take a decision. That is, but some of the procedures which suggested by the designers, we try to adopt and get back the things. Okay.
Sir, how do you think satellites will be used in the future?
Now your present trend is now actually uh, astroscience. Astroscience. That is how how the world is formed, universe is formed now, big steady, because so many stars are there, and man is try to go to other planets, and before going to population is different. I want to what you call venture to as a spacewalk. I am interested to see how the other planet. Okay, so I have to study first before going to that environment. I should study.
So you use
We have to first study the environment, that is sending a object with some detectors and study the environment. Then we have to suppose we are going ahead with actually spaces now, exploring mainly this how the atmosphere, how the stars, nearby stars, how it is formed, what the energy it contains, and what outer space, and other apart from this earth resources itself. And the earth, I want to know where the resources like water, where greenery, where forestry, where fishes. So these are all future is very important for us, because earth resources were almost exhausting also. Now we are thinking to get some resources from planets also.
So you told that we can sense the how was the star formed. How could you see? How could you sense? When satellite sense how the star was formed and what's inside it?
Yeah, actually any star, it is having its energy, that is some gamma rays, X rays. So these are all the, that is how it is formed means, that is it will be radiating. It is that energy only we are seeing as a light, or some milky of group of stars and all. So how it is formed? There are internally what is the energy it is, how the rotation it is making, whether it is any harmful to us. That is, we send a detector at particular altitude, that is in a satellite, so that will sense that energy. We orient the satellite towards that object or star and get the information. Okay.
Sir, what happens if a satellite goes off track?
Our track means we have to bring back. That is the main purpose. That is, bring back means out of track. We use thrusters, and attitude is important. Attitude means satellite orientation with the primary body. Okay, that is Earth. I take a reference. Earth, how the towards Earth, how it should be, each axis and all. So that way it is.
What advice would you give to school students who want to work in space science, sir?
Just now I told no. So space is exploring. You can yourself. You can make. That is astroscience. Neighbor. Okay. Earth resources we can, and spacewalk, and we have sent one object to Mars and all. Okay, so these are all the things. Now future is yours. We have to identify, study and show interest. Okay, and get the what you call study about the neighbor. For neighbor means what are the nearby to planet like Mars, Venus, how it is formed and all. Okay, these are all the future things. Okay.
Sir, who was your inspiration, sir, while for
No, no, sir, it is not the inspiration. Once you are showing in, have knowledge and all, it itself will be gross. Inspiration is not much.
Yes,
Okay, work makes you to improve yourself.
yes.
Sir, you told that the sun rays are too strong for satellites.
Yeah.
In which material is the satellite made of?
Very good. This is actually now we have satellite made up of with different material that but which krypton layers we say that like satellite it is like we have to maintain different subsystems different temperatures.
Yes, sir.
So for that we will have multi-layer aluminum foils. Okay, and most of the material is aluminum we use, aluminum combination. Okay, and outside we make it's like covered layers. So the whatever the inside temperature, like our room temperature, we say no, that temperature you should maintain. So outside outer space is space is made which is above 100 kilometers, 120 kilometers above Earth. Above Earth 100 kilometers. Okay, it is called space. So whichever the body there, what is happening? Temperature falls. Temperature will not be there. That is cool part. But our subsystem satellite has to maintain. It should not be. It will not work in cold. So I need some temperature maintenance in the body.
So for that we need
For-
electricity.
Which one? Want no
So for
electricity.
temperature.
Solar power is there. Electricity is solar power. Solar panel.
Yes, yes.
Solar satellite subsystems works on power subsystem, solar power, solar panels. Okay, solar panels will be there, and apart from that, batteries also there, which are all the main source for satellite, not for revolving, only subsystem.
Yes.
Okay, no fuel is required to keep in the orbit. What it makes, how it goes,
Sir, it is the natural motion of the satellite.
which injected by rocket. So there is no fuel required. But to maintain orbit, small correction
Yes.
we need.
Sir, can that layer of the satellite protect the satellite from getting UV rays from the sun or any rays from the sun?
Yeah, that is
Or like directly from the sun,
yeah,
which can be.
it protects so much. Cosmic dust is there. We don't know outer space the environment is.
Yes, sir.
So that cosmic dust and the radiation all will be protected by this multi-layer blanket. We say that like our sweaters. Sweater, how do you cover? So like that, every satellite is covered with some multi-layer insulation we call it, ML like it's a multi-layer insulation.
Sir, what is the fuel for rockets, sir? Not for satellites. For
Okay, very
rockets.
good. This is nitrates, we use it as nitrates which is highly explosive. Different types of rockets are there. We have GSLV, PSLV. Okay, GSLV means geostationary satellite launch vehicle. That is for communication satellites. That is 36,000 kilometers I told no. So for that, PSLV is polar sun-synchronous orbit for that. And recently now SLV like that small satellite launch vehicle. For these are all nitrates combination we use. These are all different combination. Nitrate is very high explosive. Okay.
Sir, what is the precaution you take before launching a rocket, sir?
Rocket so much, sir. That is very actually should not explode on that launch pad itself.
You told that we use a separate fuel for the rockets. Where can we obtain it?
That is there are so many companies are there. That is generally we import some of the explosives here itself in India. They make it. Okay, not by ISRO. We procure. Okay.
Any alternative fuel for rockets, sir, or only nitrate?
Now actually electric propulsion also is coming. Electric propulsion, but is that much trust. You have to now it is in experimental only. rocket. Now kerosene is there. One more is kerosene. Kerosene is one more. It is energy, because these nitrates and all highly explosive, and next to that is in atmosphere. It is spoiling. So now they are going for green propulsion, like that. Studies are going on.
Thank you so much, sir, for taking the time to speak with us today. We truly appreciate your valuable insights and for inspiring us with your experiences at ISRO. On behalf of our school and the entire team, I extend our heartfelt gratitude to Mr. GSV Bapiraju sir from Indian Space Research Organization for sharing such deep knowledge and inspiring words. Your dedication to science and space research motivates young learners like us to dream big and reach for the stars. Thank you so much, sir.
Thank you.